I mean 4 pi. Pardon. Sphere. Let's see. I gotta open it up again. The timer's really short. 2:30 seconds. Okay.
10 to the power of minus 35 meters. But why is this random seeming combination of constants so important? Well, it represents the scale at which space itself is thought to become quantum. I say thought because we've never been able to conduct experiments at that tiny scale. So, to understand why physicists believe this length is so important, we'll have to do some experiments in our brains. Follow me through a couple of thought experiments, or Gedanken experiments, as a good German physicist like Max Planck would call them. To start, let's say you're trying to measure the distance to an object. You shine a laser beam at it, which reflects back to a detector that records the light travel time, which also gives you the distance because you know the speed of light. But that distance measure has an uncertainty because you can only clock the instant of the...
Okay, first of all, that's not the real speed of light. That's just a relative, that is an abstract measurement, because the unit of measurement isn't a constant across all of existence. It's a constant here. We don't know how a day on Mars, you see, you have to create too many tables and conversion charts to connect all of the quantity of variables out there. There's so many conversion charts that you have to use, and one thing that's never really ever been able to be converted is from volume to weight. Weight and volume are two distinct measurements. I mean, why, when you buy a bag of potato chips and it says there are 2 ounces in there, but the volume of the bag that the bag can hold is much greater than 2 ounces. 2 ounces is a weight measure. No, it's not. 2 ounces is a volume measurement. Grams, it goes to grams. It's grams. Ounces are generally in sodas, liquids. But even there, that volume measurement. So yeah, that's what I'm. That's right. I'm confusing myself. But volume is size or area within a container. Weight is the weight without a container. So there you see the reason why let's see, which hand was volume? Volume's in both hands. But the weight is in both hands. So how is there a difference? Why can't you measure both equal with one unit of scale? Because area is the container. Volume is the container, the interior of the object, and the all of the everything around the object. That is volume. Weight is whatever's in the container, how much it weighs. Now you got volume and you got weight. You got mass and you got gravitational influence. Now you're using two different measurement processes in one formula, attempting to unify oil and water. We are all inside volume of greater and lesser impedance of expansion. This is scale time. This is matter, mass. So this is mass and gravity right here, volume. This is just matter, particles. A representation of this that can't be rectified because you're weighing it relative to a gravitational field that isn't constant over everything. Gravity doesn't pull you to the surface. You are pushed to the surface by the expanding, by the emergence of space. You're pulled. No, you're pushed. Gravity doesn't, you don't fall down, you're pushed down. You're held here by a push, by an impedance of you expanding apart and away. There's an impedance of expansion. And that's what gravity is. Gravity isn't a force in the center of an object pulling everything else into it. Gravity is folded space expanding at this very same constant that empty space is expanding at, but there's just more of the space mushed in to one point because space is the equal amount of space is coming out somewhere. So you oh my God. Okay, let's just continue the video. Ooh, I sounded country. All right, let me open this up again. Here we go.
The return to within one wave cycle of the electromagnetic wave. That gives a distance uncertainty of around one wavelength of whatever type of light you're using. Okay, easy enough. Just use a very short wavelength to get a very precise distance measure. But now you have a new problem. Light carries energy and momentum. The shorter the wavelength, the more it carries. You bombard your object with a powerful short wavelength X-ray laser, and you may get an amazing distance measure, but you'll transfer a lot of momentum. You can try turning down the power.
And that's because of the there's not a real full understanding of what momentum is. And because it's measured abstractly. Because it's the illusion presented to your mind, to your mind's eye by the mechanism of the conglomeration of fields that mechanized to become your brain is itself mechanized fields. And these mechanized fields Just like any transmission and receiving device, it's tuned to the carrier. And all the modulation within that carrier wave can be discerned and decoded. So the mechanized field, sum decodes an environment and broadcasts it to your mind. The brain is a mechanized field sum. Just like the majority of existence is all of existence is composed of fields. However, the animate and the conscious, the animate are mechanized field sums. So your mind is in there just pulling levers. Okay, save this, save that, and that's a whole nother deal, but whole nother series. But that's what your consciousness isn't. Feels on the brain, the physical brain, and is the mechanized. Is a sum of mechanized fields that broadcast